Let's take a look at an example from section 4.6. We're given a set here, S, which is a collection of a bunch of 2 by 2 matrices with real entries. And we're asked to determine if this set S is a basis for M2R. Now, if we go by definition, we have to show two things. In order to show something's a basis, we have to show that it is both a spanning set and it's linearly independent. But using the ideas from section 4.6.3's video, the basis and dimension theory, we can note right away that the dimension of M2R is 4. So a basis requires 4 vectors, which we actually have here, right? 1, 2, 3, 4 vectors. Now, by our dimension and basis theory, we either have to show simply, since we have dimension 4, that our collection of 4 vectors is either linearly independent or it's a spanning set. So, if we simply take the augmented matrix, so we will show linear independence. So the augmented matrix looks like in columns -2, -8, 1, 4, 0, 1, -1, 1, -5, 0, 5, -4, and 3, -2, 4, -1. And then, of course, 0, 0, 0, 0, as we're doing linear independence, and we have this system set equal to the 0 vector. Now, you can row reduce this, and if you do row reduce this and put this in RREF form, you're going to get 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, and 0, 0, 0, 1. And then, of course, zeros on the back end. This is the RREF of the augmented matrix here. And that is going to tell us that our only solution for the C sub i's in the sum of the C sub I V sub i's equal to the 0 vector must be that C sub I equals 0 for all I. And thus we have S is a linearly independent set. Now, aside here, we could have done this another way. We could have taken the determinant of the A matrix and shown that that was non-zero, and we would have also got linear independence. That might have, I don't know, that's quicker than row reduction. It's up to you. There's not a whole lot of zeros in that determinant, but you could have done some row reduction and used some of the fancy techniques from chapter 3 to get that done. Let's see, and then continuing on, using our theorem, since the dimension of M2R is n and S contains n, I don't know why I wrote n there, 4, and S contains 4 linearly independent vectors, S must also be a spanning set, in which case S is a basis for M2R. The end.